Good morning, fancy meat computers! How is everybody doing today? I hope that you're having a good morning. Oh, I've still got Python stuff up. Python. Who programs in Python? Jeez. You guys just had a test? How was the test? You guys had a test? What test did you guys have? Might have been terrible, hard to tell. 50 minutes is pretty short, yeah. Oh, dynamics, yeah. Let's see, we were on arrays. Uh-oh. Uh-oh. It looks like Pedro's having a meltdown. Pedro? Breathe, man. Breathe. Just remember to breathe. Did you guys, like, just have the test? Is, like, the test, like, immediately before this? Yeah. See, this is why I prefer, like, the 24-hour test model, because it's, like, you can accuse me of many things, but not giving you enough time is not one of the things you can accuse me of. Although people do still actually accuse me of not giving enough time. It was at 8:30. You had a 1 hour break. It ended at 9:30. Oof. So you guys are still in like test brain, you know? Okay. You know what? We'll do some breathing exercises, okay? Breathe in. Breathe out through the mouth. Like you're breathing through a straw. Breathe in. When I was in the second year of the program, when I was where you guys are right now, I took up Tai Chi. I found it very helpful. I actually, I met a friend who is still a friend of mine after all these years, because he was having test anxiety outside of one of the testing halls in this particular week, and I showed him some breathing techniques that could help, calm you down, lower your blood pressure, and we're still friends today. So that's the power of Tai Chi, my friends. This test required reading, thinking, and writing. Oh, that's the triple threat. Another midterm at 6. Gross. Still need your test brain for statics. Oof. I don't get why Tron people have to take statics. I know it seems like it's designed for civil people, because it is, but you need to know statics because well, it's one thing to be able to model mathematically the movement of mechanical parts. It's important to be able to do that, right? But it's also important to be able to know, like, what stress and strain is, and think about think about your robot arm, right? If your robot arm is lifting something, one point of failure is like the joint mechanism, but and like how the joint mechanism moves, right? But another like a point of failure with that is like the forces of stress and strain and like torsion inside of the components of the robot arm itself. Like, in order for the robot to be effective at doing its job, it needs to be able to withstand the forces applied to it, and that's what statics is, as opposed to dynamics, right? I don't need to tell you this, of course, because you guys are actually taking courses, but you're sure you already know what stress is? Yeah, I know, but it bears reinforcement, Personally, I really liked statics and dynamics. Like, they were, maybe they've gotten more difficult since I was in, but I don't know. I found it like, yay, cool. I'm learning mechanics. This is fun. I'm actually doing the thing my degree is supposed to teach me. I just realized you guys had the 2E lab, then 2 midterms. Oof. Aren't you glad you don't have a midterm from me this week? Anyway, so, hanging on by a thread. All my Eng Fizz bros, give me a whoop whoop. So, anyway. So we talked about macros. So let's talk. Let's do. Well, actually, I should check the announcements feed, shouldn't I? Doop-a-doop-a-doop. Okay. When was October 1st? That was Friday at 10:30. That would have been immediately after class. So I'll say it again. So I noticed I was getting some invitations from like the wrong GitLab server. Like, it was not the departmental's GitLab, but like some other GitLab, possibly GitLab server. Please use the official one. If you haven't, please email me now, and we'll get it sorted out. But yeah. Ah, there we go. AJ, whoop whoop. There we go. What is even going on in math? That's the eternal question. So, so let's continue our discussion of arrays, which are hopefully, this is like not super difficult material, so it can still be like listened to and understood by your, it's like, if right now your brains are a boat and the cargo is the knowledge, and you guys are like riding very low on the water right now, hopefully the few crates that you have from me to deliver to Seaport are not enough to capsize you. So so arrays and functions. So we now know what an array is. It will be useful to be able to pass them to functions. So consider the following function prototype. Int star myFun takes a constant integer input, which is also an array. I capsized an hour ago. Yeah. Input is declared as an array by the inclusion of the square braces. So that's relatively easy, right? The same thing that declares an array as being an array when you're declaring it, in the regular execution of the program, that's the same way that you declare it inside of a function. So that's easy enough. Int star is also, however, valid, and this is an interesting one. So star, as we're going to see, is how you do pointers. So pointers and arrays, when they're the input or output to a function, are more or less interchangeable. Int star tells us that this function returns an integer pointer. Arrays in C are syntactic sugar for pointers. The constant term locks the pointer so that it can't be modified. This essentially makes it read-only. So you can modify the individual values themselves, but you can't modify the address that these... Well, it doesn't matter until we talk about... It'll make more sense when we talk about pointers. Essentially, you can use the const keyword to make any input to a function read-only. It sort of removes writing permissions for variables. And like when you're thinking about things like variables having permissions, like really just insert your knowledge of how the file system works and that'll be sufficient, you know? So, if you want to be able to modify the array, just leave out the const keyword. You can do this with any argument, not just arrays. Oh, size of. That's the LaTeX tag for this, like, blue teletype text. But anyway, sorry, that's a typo. In Python, we have the length function to quickly and easily tell us how large our data structures are. The equivalent in C is size of, but as with most things in C, it's a bit more complicated. For one thing, size of returns the size in bytes of the thing that you're providing as an argument. So you can use size of on variables of any type, not just arrays, and you can also use it on data types. So, for example, you can get the size of an integer. Let me pull up the let me create an example thing here. Yeah, that's from last week. Topic 5.2.c. Get it? There we go. Oh, what? There we go. So, include stdio.h as per the usual int main printf. Size of int. Double. Char. So, let's compile that bad boy. GCC topic 5.2.c. I've got some... okay, so it's a long unsigned int that it returns, not a regular integer. It'll still work, though. But what is it? At UL D? Is that how it works? Let's see. Yeah, UL is long unsigned. Just to get rid of those warnings. A dot out. So, the size of an integer is 4 bytes, the size of a double is 8 bytes, and the size of a char is 1 byte. So there you go. So, in order to find out the length of an array, int, like, foo, you know, I mean, if you used a define statement to determine the size, then you don't need to do this, but, you know, it is what it is. There we go. Printf. Oh my god, I hate the braces. But, you know. Better than my wrists exploding, I suppose. Size of foo divide by size of int, because it is an integer array. And if we run that, it will, I forgot the new line, but you can see size of foo is equal to 10, which is correct. So that's how you can reconstruct this. One problem, though. Size of doesn't work inside of functions on arrays. So very often, like if you take a look at the assignment, I posted the assignment 2 document this morning, and if you take a look at the first question there, you'll notice that it's asking you to do some like relatively minor statistical operations over arrays. You know, like take the average of an array type thing, just to get warmed up. And the array is the first argument, and the size of the array is the second argument. And the reason for that is that array sizes, like the size of function, won't tell you what the size of the array is inside of a function. It'll tell you that the size of the pointer is inside of a function. So that's a problem, so to speak. The so basically you have to do this type of operation inside of the context in which the array is created, and then pass that value into a function in order for the function to have that information available. The reason that this works this way and not, you know, the reason that it doesn't work like it does in Python is that when you're talking about a list in Python, you're talking about a fairly complicated thing, right? It's been designed using the object-oriented facilities of the language, right? So that means that it can use extra fields to keep track of data about itself. And one of the things that it keeps track of about itself is its own size. Arrays in C do not keep track of any information about themselves. They don't keep a track of where they stop and start. They don't keep track of how big they are. They don't keep track of any of that information. That's your responsibility as the programmer. So that's how that works. The declared length of an array is equal to the size of the array in bytes divided by the size of any element of the array in bytes. Yes. So you can change this out for like foo 0 if you want. If you forget that it was an integer and you just don't care to look. Ugh, pardon me. I love seeing like the classic shrug emoji. I love it when people use it. So question. If you had all the elements in the list the same, but one of them was a long integer instead, would it change the bytes needed for the character and cause the code to be different in length to be different? The problem with that, David, is that you're not allowed to put a long integer into an array that contains integers. Arrays in C, as opposed to lists in Python, are monotyped. You're not allowed to have anything in here except for the declared data type. Otherwise, it's a type. Well, it'll give you a warning. What it would actually do is it would take your long integer and then it would truncate it so that it would fit inside of the integer space, I'm pretty sure. I'm pretty sure it would truncate. But it's like what happens if you assign... oh, here's a question. If I have a long int bar, which is hexadecimal 2, 3, 4, 5, 6, 7, 8. We haven't done hexadecimal yet, but, you know. And then I have integer baz, which is 0. What happens if I print... what happens if I assign bar to baz? So bar is too big to fit inside of baz, right? Printf. I think x will be hexadecimal. All right. Now let's compile her up, see what we get. X. Expect unsigned integer. I'm going to make all of these unsigned, just for the sake. There we go. So, that's interesting. So, wait, have I got this right? No, I don't. That's 8 times 4 bytes per hexadecimal character is 32. I want yeah, I want more Fs. Press F in chat. So that's the size of an unsigned long int, I think. Yeah, there we go. So, notice the size of the integer going into bar. Like this essentially is shorthand for flipping every bit to 1 inside of a long unsigned integer. Baz is originally set to 0, but via this assignment, only that portion of this guy which fits inside of bar is actually put in there, right? So if I were to make this a little bit more interesting, F, oh my god, alphabet backwards, E, D, C, B, A, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. That's 16, right? Should be 16. Definitionally, that's 16. So, you'll notice that just this back half of the integer gets stored. So basically, this is what would happen. Like, this is what happens when you try to store something in a slot that's too small for it. Any overhang is just chopped off and discarded. So that's the same thing that would happen inside of your array, right? Because writing the process of writing to an element of an array is the same process as writing to the element, like writing to any variable. So that's what would happen in your particular case. But we gotta keep moving on these slides. So, accessing higher dimensions. Linear arrays are all well and good, but what if I need to represent a matrix? Not the matrix, a matrix. Incidentally, did you know that the word matrix derives from the same root as the word maternal. It's like the matrix is sort of the mother substance of which reality is constructed. That's another term, that's another meaning of the term matrix, which is why they call it the Matrix in the Matrix movie. But yeah, so you can nest these things. You can declare a 2D array by simply including two braces, one after the other, two sets of square braces, and then you can nest these declarations inside of each other, and you access them just by providing however many whatever the dimensionality is, provide an index for each one of those dimensions, and there you go. This is actually being stored all linearly in memory, but, you know, that's neither here nor there. Question. So I don't know the sizes for long int and int, but if, let's say, the max on a regular integer was 10, and we had int equals 90, or was that 900,000, would it truncate to 9? No, it would truncate to it wouldn't truncate, right? Truncating is like cutting off the end. It would cut off the front, so you'd end up with 0. Right? It takes the lower half and inserts that in, which is actually usually correct. But yeah. So, dimensionality is indicated by the number of square braces following the identifier. These are correctly thought of as arrays of arrays. Providing k minus 1 indexes to an n-dimensional array will produce a k-dimensional array. So, if you have a 2-dimensional array and you supply it one argument, you end up with a 1-dimensional array. Particularly, that 1-dimensional array which sits at the index that you specified. Can CTutor use the math library? That's a good question. You should try to find out. Report back. So, strings are character arrays. There. Corporate needs you to find the differences between this picture and this picture. Hello world and hello world, an array of characters including null termination. GCC says they're the same picture. Memes. So, character arrays, not character sheets. As it turns out, C handles strings as character arrays. Consider the following declarations. So this is how you actually put a string in memory, because C doesn't have a native string data type. It has character arrays, all right? So you declare a character array and you store a string in it. So char foo is bar. Foo will be written into memory as the character B, the character A, the character R, and then null termination. If we specify a size of 10, then we get BAR null, 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 null. So in the same way that an array will backfill with zeros, if you underspecify the size of the initializer, the same thing happens with character arrays. So this is the same rule being applied. It's just with the null character, the encoding of the null character in terms of binary code is all zeros, which is also what that's also what you backfill when it's an integer, right? So you backfill with null characters. It turns out that it's actually super, 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 super important that that strings have this null character at the end of it. You remember how I said that arrays in C don't know how big they are? Well, that one way of solving that problem is by putting a known character at the end of your array, so that if you're scanning through your array and you hit that character, or you hit that arrangement of bits that you know is only used to terminate arrays, then you know that's that's the end, so you can stop doing stuff, right? So it's tricky with integers because, arguably 0 is a perfectly legitimate value a lot of the time when you're working with integers. But the null character has no interpretation like, if you try to print the null character, it doesn't print anything, right? The null character has no purpose other than to terminate things, right? It's a unique arrangement of bits within the world of characters. So we can use it to indicate the end of a string, which is good. So basically, this is a long-winded way of saying it. If you have a character array and you specify 3 characters because you need 3 characters to store bar, right? If you try to use any of C's built-in functions that operate on strings, including trying to print it, you're going to end up with an infinite loop, because C's inbuilt functions are expecting a null terminating character, but it's not going to have that because you only gave it 3 characters for the 3 characters you thought you were storing. In C, anytime you use the double quotes here, there is another invisible character at the end, and you have to take it into account when specifying the size of things. The easiest thing to do when you have a string literal that you're trying to initialize something with is to just not specify the size. Then you don't have to worry about it. It figures it out itself. Everything's hunky-dory. Null is 0 before 0 existed. Yes. So yeah, so that's how it works. That's how strings work. String isn't even a keyword in C. Characters may be indexed just like regular arrays, so you can access the elements of a string the same way that you would access the elements of an array. String literals are always terminated by the null character implicitly. All strings must be null terminated. We can receive strings directly from scanf using the %s format specifier, such as scanf %14s and foo. By inserting a number, the format specifier may even be used to limit the number of characters that get copied into the character array. This is useful. We're going to go over how this is useful. Foo is actually a pointer, so we don't need the address of operator in scanf. Foo is already a memory address. And we're going to go through an example of how this works. So, question. So if I tried to find the length of foo10, the foo10 string later using size of, it wouldn't return 10, since it would stop reading at the first. That's a good question. So that's a good question. Let's try it. So let's say we had char foo2 10 bar. There we go. Printf size of foo2 equals long unsigned size of foo2. Now, I know that characters are of size 1, so I'm not going to include the division by the first element, because I already know that it's 1. And division by 1 is always has the same result. So let's see what this does, shall we? I suspect you're going to be wrong, but let's try it. Oh. I should include my semicolons. I forgot the, always forget the new line character. There we go. Size of foo2 is equal to 10. So the size of the size of function is not like a string function, right? It's not built to operate on strings. It's built to operate on arrays. So when you pass this character array into size of, it deals with it as if it were any other type of array. So it measures it the same way it would measure any other array, which means it includes the null characters. And when we get into the string, like, we don't talk about the string functions until, it's going to be a few weeks at least. But when we get there, they do also actually process the null character. It's just anything beyond that, they won't deal with it. But yeah. So, overflow attacks. Ho-ho. So this is another reason that C is considered an unsafe language. A common form of security vulnerability in C and C++ programs is array overflow. During an overflow attack, arrays are replaced with pointer... Oh, no, this isn't during an attack. This is a generally applicable truism. Arrays are replaced with pointer arithmetic by the compiler with no bounds checking. If you tell C to write 100 characters into a 50-character array, it will happily do so, and will overwrite anything that comes after that array. The extra 50 characters will be written into memory that comes after the array. This can overwrite all kinds of useful things, like other variables. If the character array is stored in the stack, function call information can also be vulnerable. The moral of the story is that you should always limit the things you write into an array to the size of the array manually. So, question. If we measured the length of an array with null terms, what would happen if the element we divided by was the null term? The size of the null term is, like, it's a character, so its size is 1 byte. Size of null is 1, so you wouldn't end up with a zero div error. If you divided by a null character, you would end up with a zero division error. But the size of null is 8 bytes because it takes, 8 bits, because it takes 8 bits to write the null character, right? Even though it contains 0. So here's a short program. So if we have a query, right, and this just takes in a query and then outputs it again. This is a vulnerable program, and I'm going to reproduce its vulnerability. I'm going to just comment this junk out for a moment. Probably permanently. Because who's going to come back here, you know? So, char query takes 10. Printf, enter a query. Scanf, %s, give it query. So query is where we're going to store it. Printf, the query is s. Query. There we go. So let's run this bad boy. So it would still find the length. Yes, it would still find the length. Enter a query. Blah. The query is blah. Very good. Everything is working the way we expect it to. What happens if query is longer than the stored... What happens if the query we enter is a little bit longer than the space we've given it? So query is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Haha. Stack smashing detected. Terminated. But does that happen each time? So basically, what's going on here is when we try to write, like it sometimes depends. I was kind of hoping that we would be able to, you know, there would be a bit more of a bound on it. But if you're overwriting if you're overwriting areas, or if you're, what stack smashing means is that you're trying to smash the call stack. That is, you're trying to either you're trying to write to places that don't belong to you, right? Write to or read from places that don't belong to you. So it's kind of related to a seg fault, but it's like if you have a seg fault and it occurs in stack memory rather than heap memory, you get a stack smashing rather than a segmentation fault. But it's basically the same type of error. Yep. There you go. Good. So, with 10 minutes left in class, we're going to talk about some algorithms. You guys, hopefully this, like, I don't know to what degree they talked about, like, sorting algorithms and that sort of thing in whatever your new, I always forget the course code, it's like 1P13 or something. Like, they broke the convention by including, like, 3 numbers and a letter instead of 2 letters and 2 numbers. But your first year Python course, to what? Here's a question. Did y'all do sorting algorithms in first year? Sorry, when is the second assignment due? Not for a while. Let me see. Content. Overview. All of the everything is in the course outline. It says it's due October 17th, which is probably... Yeah. October 17th. These are bi-weekly assignments, so yeah. October 17th sounds about right. Assignment 2 is due October 17th, so you don't have to worry about it this week. So, who can explain... although I might, depending on how much of this we get covered this week, yeah, I might push it back a week, because, like, you really need to have done this entire slide set before attempting the assignment, so I might push it back a week. We'll see. I'll let you know. 50-50, eh? Yeah. What's the sorting algorithm again? Ha! Well, aren't you glad that we're doing it right now? Are all the assignments due on Sundays now instead of how it said Mondays at the beginning of the course? Let's see. Yeah, it was just a couple of them that, like, I had made a typo. But, yeah, no, everything's on Sundays now. Sunday midnight. Sunday midnight. So, this is a comic. Who can explain frog sort algorithm? These are cave people. Start with empty list. For each integer, put that number dead flies in one box. Then put frog in each box. When frog leave box, append that box's fly number to list. More fly take longer to eat when all frogs gone from boxes list ordered. What is maximum step number? Log frog boxes. Very good. Now homework is program frog sort on home frog pewter. Later. Bah! Me keep getting off by frog error. It's funny. So, the importance of sorting algorithms. Sorting algorithms are one of the oldest areas of algorithm research. The first formal analyses of sorting algorithms began in the 1950s. The 1950s and 60s was like the time to be a mathematician studying computers, I tell you. Many are necessary because there is no best algorithm for sorting. Each of the sorting algorithms, each of the prominent ones anyways, are better for certain situations as opposed to others. Different sorts perform better under different conditions. Some sorting algorithms perform best on partially sorted arrays. So, you can measure the degree of sortedness of an array by how far off any particular element is from where it should be if the array was sorted. So the lower that number is, the better an algorithm like insertion sort works. Others are better if you optimize for runtime memory or call stack usage. So, some are only useful for, some are very, very good for, very, very small portions, right? Some are very, very small systems. Like shell sort, for example, is used commonly in embedded systems because it's highly, highly memory efficient. And it's the code itself doesn't occupy a lot of space. Despite the vulnerable status of sorting algorithm research, advances are still being made. So in 2002, an algorithm called timsort was developed, which is actually the one that Python uses. It uses ordered subsequences to improve performance. And library sort allocates extra memory to quote-unquote gaps, which allow the insertion of entries without reorganization of the entire array. Think about how books work in a library. In libraries, they leave a little bit of space at the end of the shelf so that they can insert books into the shelf without having to move books from the end of one shelf to the next each time, right? They don't compress everything. Man, if I had only known about library sort when I was a kid sorting my Pokemon cards, I tell you, in the albums, right? Best sorting algorithm. 1. Randomize all in the list. 2. If not sorted, destroy the universe. Yep, that sounds about right. So, how is a sorting algorithm defined? A sorting algorithm is used to rearrange a given array or list of elements according to a comparison operator on the elements. The comparison operator is used to decide the new order of elements in the respective data structure. So, normally, when you're talking about numbers, we all know what sortedness means when it comes to numbers. If you're talking about something like characters, you can either refer to lexicographic ordering, which is basically how the dictionary orders characters, or you can order characters over the ordinal numbers, that is to say their underlying ASCII codes. So, the input to any sorting algorithm is an array of values of arbitrary size, and the output is an array of values of the same size in which the values are in ascending order. So, normally, when we talk about sorting algorithms, we'll always be talking about going in ascending order, just by convention. Obviously, if you want to do descending order, it's simple enough to convert an algorithm from ascending to descending. You only have to flip one character in the program. So, it's considered trivial. So, bubble sort. Bubble sort is the basic bitch of sorting algorithms. It's not very efficient, but it's easy to understand, and is therefore the first one we're going to do. Bubble sort's basic operation is to examine two numbers and swap them if they are in the wrong order. It starts at the beginning of the array and examines each pair of consecutive elements until in the order that they occur in. After one pass through the array, the item at the end of the array is guaranteed to be in the right place, which means that the next pass can safely ignore it. Bubble sort will make n-1 passes through a given array of size n. By the end of the n-1th pass, the whole array is guaranteed to be sorted. So this is how bubble sort works. You examine the first. They're out of order, so you swap them. Next, these are out of order, you swap them. Swap, 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 swap. So it just so happened that our 9, which should be at the back, was at the front, so it got swapped through, like each one of these operations swapped it. In this case, 4 and 7 are in the correct position. Like, they're in the correct positions relative to each other, so you just leave them, right? Then the next one, swap, leave, swap, 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 leave, swap, swap, leave, swap, leave, 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 leave. And by the time you're finished with all of these, you'll notice that the number of numbers that are like correctly positioned increases by 1 at the end of each one of these swap chains, right? And by the end, the last 2 you get for free, right? So that's how bubble sort works. And I'm out of time, so we'll do the analysis of it next time on Mr. Moore's class on programming. Ha! There we go. Any questions? If not, I'm going to go get lunch, because I've got another class after lunch. So it's good to have lunch. How should you prep for the midterm after reading week? It's going to be on programming problems, so the best I'm not really so concerned that you guys like have memorized all of the ancillary information in the course, but there might be a few questions on like how compilers work. I believe I have to test you on how compilers work because it's an accreditation requirement. You guys have to demonstrate knowledge of how compilers work. So there might be a few questions about that, but other than that, we're going to keep it to primarily programming problems. So the types of problems that you have been seeing in assignments 1 and 2, those are the types of problems that you can expect on the test. You might also expect some stuff on pointers if we've gotten that far. If we have questions on pointers, they would be relatively simple, because pointers get more complicated as you go on with them. Slides. Yeah, after this is our topic on pointers, so probably we'll have some pointers on the exam. Exam, test, midterm. That's what I meant. Ha! Is the midterm like questions we answer or problems we code solutions to? Bit of A, bit of B. Mostly B. Yeah, mostly problems that you're going to be writing code for. For me, the practical skill that you should have at the end of all of this is being able to program in C. So programming in C is what I'll be testing you on. Y'all have midterms on the brain. Midterm isn't for another month yet. So, well, 3.5 weeks anyway. We submit all this on GitLab, right? Yes. Everything gets submitted through GitLab. Thanks for the midterm pointers, sir. Blah! Yes. Yes, good show. Excellent, excellent. Oh, yes. Very good, yes. I appreciate the pun. I do. Okay. Well, if there are no more questions, I think I will end the stream here. On assignment 2, you have to implement bubble sort. That's one of the questions. October 23rd is 2 weeks away, lol. Oh, if I got it down for October 23rd? Oh, I'm sorry, guys. I'm mixing up my midterms. I've got, like, most people have, like, put their midterms before reading week, but I decided to do it, like, in the, like, 2 weeks after, so I've got, like, this cluster of midterms coming up. You know, not unlike the cluster of midterms that you guys are dealing with this week. So, yeah. Is it... Let me just take a look and see. Yes! Okay. So, your colleague is correct. The midterm is currently scheduled for October 23rd, which is... that's the week after we come back from the break. At the end of that week, we will have the midterm. Which means that we won't be covering pointers on the midterm, because we won't be able to cover it. Okay. Right. That's fine. Pointers on the exam, then. Ugh. Alright. Maybe I want to push... Nah, I've already... I'm a man of my word. I must hold to when I said the midterm would be. Sorry. Yeah, okay. Cool. Alright. Anyway, take her easy, folks. Don't do anything I wouldn't do. Peace out.